We're coming in hot. This live stream is off the hook. You guys are really going to love this one. As you can see, right next to me, we've got a nice little stage camera set up with a nice little robot set up. We're going to go into that a little bit later. But I'm so happy for you to join us. Welcome to another NVIDIA Omniverse live stream. I'm Edmar, the community manager for NVIDIA Omniverse. Today's stream is all about taking robots from development to real-world deployment, specifically using Isaac GR00T and Jetson Thor. We've got two very awesome guest teams joining us today. Noble Machines will first show us how they built Moby, a general-purpose industrial humanoid robot, going from founding to shipping in just 18 months with a team of 15. They're going to walk through how they use Isaac Sim, Isaac Lab, GR00T 1.7 with policy training, and Sim2Real transfer with onboard inference running on Jetson Thor. It doesn't stop there. The second half, we got Seed Studio going to take us through an end-to-end developer path with the reBot arm, covering data collection through teleoperation, simulation, training, validation, post-training, GR00T 1.7, and running policies on real hardware. They're launching a brand new physical AI course designed to help developers bridge the Sim2Real gap. We're going to talk about all that and more. Plus, on the NVIDIA side, you can see some of my colleagues with me below. We've got Brandon Neal kicking things off with an overview of Isaac GR00T, plus my awesome colleagues on the community side, Johnny and Asir throughout. We want to encourage your questions and comments throughout the live stream. The more on topic they are, the more likely I am to show it on the screen and we can talk about it. All right, let's do a quick round of introductions so everybody can know who's here, and then we'll bring people back up for your part of the presentation. Let's start. We'll skip the robot for now, but we're going to go right to Elaine. Elaine, so happy for you to join us here with your colleague.
Thanks for having us. I'm Elaine, head of AI robotics at Seed, and next to me is Yu Zhang, our application engineer. It's great to be here to share our new journey and collaboration with NVIDIA for a VLA pipeline using our robot arm and Isaac Sim.
I'm very excited to show off what you guys have built. It's so impactful for developers. So thanks for joining us. Asir, how are you doing?
Good. We are here in the Seed Studio offices, and I am part of the physical AI team. I was in charge of the adaptation of Isaac Teleop during the GR00T launch with the robot, and I did some examples on XR with Oculus. So later we will speak a bit more about the teleoperation part.
I'm very excited to have you here. Thank you, as well as my colleague Brandon. Hey, Brandon.
Hey, happy to be here. I'm Brandon. I'm a product marketing manager on the robotics team at NVIDIA, specifically looking after NVIDIA Isaac GR00T.
Amazing. And right next to you is our amazing community evangelist, amazing developer who works with developers all over the world. Johnny, how you doing, Johnny?
Hi everyone. I'm Johnny, based in Barcelona. So I'm from physical AI team. My co-workers is Asir, and a lot of members from community knows me about all my contributions in Jetson. So yeah, that's it.
Well, we're very lucky to have you join us today. Last but not least, Wei, so happy for you to kick things off today. Tell everybody a bit about your role.
Hi everyone, I'm Wei. I'm the co-founder and CEO of Noble Machines. I have a software background, and now most of my time as a CEO is PowerPoint and email. But it's very fun to see a robot grow from zero to our customer's hand and witness the development of the industry. It's be very exciting.
We're so honored to have you here. You've got some great content planned. Before we jump into that, I'm going to drop a few of you down below, and I'll bring you back up in a minute. But we would like to kick things off with Brandon, because Brandon, you're going to kind of set the stage and kind of let us know what we're in for the next hour or so. Why don't you? I think you have some slides too, right?
Yeah, thanks. Yeah, let me kind of present, and I'll just give. We're going to be touching on a lot of topics today. Isaac GR00T is going to be one of those main topics. So I want to give everyone just a quick refresher, like a 1-minute refresher about what is NVIDIA Isaac GR00T. So we recently launched Isaac Groot 1.7, which is our open vision language action model for generalist robot policies. What's new with 1.7 is that it has a commercially viable license, so it's ready for production deployments. It was pre-trained on about 32,000 hours of real demonstration in human egocentric data, so more human-like emotions. It has Cosmos as the VLM backbone for better visual language reasoning and spatial understanding. And it also has improved long horizon task reasoning, reliability, and some cross-embodiment generalization. So the main thing I want to call out is that 1.7 is available now. You can find it on GitHub as well as on Hugging Face. We also have the NVIDIA Isaac Groot humanoid development platform, which was also recently released. So this is a fully open, validated platform that brings together kind of every stage of the humanoid development. So from data collection to policy training, evaluation and deployment. And then once you deploy onto the real robot, it is powered by Jetson Thor. So this platform is modular, it is extensible. It allows you to kind of just use the components you want to use and integrate your own tools into it. We have on our physical AI learning center, and I'm sure we can share the link in the chat as well, both like a simulation and a real workflow, reference workflow that can help any developers kind of get started developing humanoid robots and the policies, and it's kind of just like a step-by-step guide that'll take you through all of the stages that you see here. So please note that we'll be kind of touching on some of these aspects during the live stream today. But yeah, just want to give a quick refresher on everything new and recent with Groot, and we have a lot of great content to get to. So Edmar, I'll pass it back to you.
Okay, awesome. Well, that was fantastic. Thank you, Brandon. Well, I'm going to pass it off to Noble Machines. Wei's right here waiting. Wei, so glad to have you join us. Thank you so much. Super excited. I know you've got a hard stop in about 25 minutes or so. So you can go ahead and dive right in.
Excited to be here. I'll give a quick background of Noble Machines and dive into any topics we have. So Noble Machines, we build general purpose robots for industrial work, especially those dangerous and backbreaking jobs. Thinking about industries like construction, manufacturing, logistics. We are a full stack company, so meaning we build hardware, we build whole body control, and we also build autonomy. We are like our autonomy, our software stack involves, as mentioned, whole body control, which we are trained in pure simulation. Today we use Isaac Lab. We built our training pipeline on top of Isaac Lab, and then we have a very high success rate of Sim2Real deployment pipeline. We can almost achieve the same performance on hardware as it is when we see on the simulation. On top of the whole body control is our autonomy stack, which today we built our training pipeline and data pipeline leveraging NVIDIA's Groot, but our pipeline is really set up to be able to collect data from hardware and manage data and fine tune in a very seamless fashion. So that's pretty much the technology stack of our product.
Absolutely amazing. I'm actually showing you a website on screen, so everyone should check it out. Just go to noblemachines.ai. Really impressive stuff, Wei. Now, I know you also provided some videos here too, right?
Yeah. So we can. Do you have the screencast video? That's the.
Yep. So let me see. I've got a few queued up here. I've got. Let me see. I've got the evergreen one. I've got the dynamic payload simulation. And let me see. Is the screen recording? Let me see. Is that the one you're looking for? Screen recording?
Yeah, that's the screen recording.
Let me see.
Exciting that we're enabling data generation.
Not it. That's not it. Yeah, I don't see the screen recording one. I have the sim video, the dynamic payload, evergreen, and the some clips from the automate.
I can share it. I can share the screen. Let me share the screen.
Okay, and while you're doing that, we invite your questions and comments from the audience. Again, we have the CEO and founder of Noble Machines here. So queue up your questions for Wei. And then following way, we have a Seed Studio. And I see your screen. I'm going to put it on the screen right now. There it is. Okay, we see it.
So taking, let me take you from of the journey of how we like build the software for Mobi. Right. So this is pretty much the first stop, where we what you see is the Isaac Lab training scene. We put the digital version of the robot, which is USD file, into the training environment. This is one set of the environment. We actually have a much more diverse environment. So what we are doing is like having a lot of robots like training in this different. Some are going through stairs, some are going through rugged terrain. Then with that, we have a model. Then we that will go through a Sim2Real process, where we test it in a real hardware, and we get the feedback and further improve the training pipeline. The reward, for example, reward tuning, curriculum tuning. So then pretty much the model will work on the real hardware. So this is the training environment. And we also can you bring up the payload?
Yes, let me bring that one up. I'm going to remove this one for a second. Okay, and here it is, the payload one.
Can you get the so like what we are showcasing here is what we can get from the training Isaac Path. So you can see the system is pretty adaptive. First of all, the system is pretty adaptive, but more important is very adaptive. It's adaptive and also when we throw a weight the model running out of that's because during the training process, we have a very diverse set of situation. So the robot pretty much has witnessed a lot of diversity of interacting with payload and interacting with environment. So in real, a robot is much more robust against variations in the real world.
Thank you so much. I want you to maybe repeat the first part of that, because when the videos include audio music like that, I have no way to silence the video actually. So you were a little hard to hear in the beginning of the video when the music was happening. So let everyone know, just give a quick update on what we just saw in the first part of the video.
So what you saw was the ability of Mobi to be able to handle high payload is 50 pounds. 50 pounds is about 25 kilograms for those who don't speak pound. And more important, that's a sustained payload, sustained operational payload, meaning the robot is able to hold and operate with 50 pounds. That's one thing. And second is the ability to adapt to the changing payload from 0 to 50 pounds. And you may also have seen the other robot, maybe the yellow color, throw weights to the second robot. That actually changes the weight distribution of the payload. And so the key there is that the robot is able to handle changing payload and changing weight distribution. That's because in the training process, we have a lot of randomization happening in the training process. So the robot has witnessed a lot of different variations of terrain, different variations of payload in the training process. So in real world, it's much more robust.
Wild. Okay. And we have another one here too, the simulation video, I guess. This one I think also has audio. So if you want me to play it, maybe just give a quick intro of what it is, and then we can watch it.
Which one?
Go ahead. What would you like me to play next?
Maybe we can maybe we can mute the audio.
It doesn't let us do that. Unfortunately, I need to have the video without audio to begin with.
So we have, so simulation is incredibly important for us because it's a much low cost and fast way to validate the system and how it works in customers' environment. So next video, I assume, is the video of a robot walking on a construction environment. So that is a collaboration we have with a customer who is a pretty large construction general contractor. So they provide us their digital environment, and we put our robot in the environment. So serves two purposes. First, we can very quickly see what kind of use case we can we can help our customer with. Second is that before we actually deploy the robot to real environment, we can train the robot in a simulation environment. So like before we ship the robot out, we pretty much have a much better, much higher confidence our robot can solve our customer problem.
This is
So that's
great. Amazing. Okay, let's watch this, and we'll be back in just about 30 seconds or so. This is great. That is wild. Very cool stuff.
So there should be another video that's pretty cool I would like to show. I haven't showed that a lot to other people. It should be the outdoor stairs.
Let me see. Is this the evergreen one?
That's not the evergreen one. There should be an outdoor stairs file. So that video what we're trying to show is the ability to navigate different environments.
Okay. Yeah, I'm going to ask our producer, Amelia. Amelia, I don't have that video uploaded here. If you're able to grab that somehow and upload to StreamYard, I can play it. In the meantime, I do have the evergreen video queued up, and I also have the Automate clip. If either one of those makes sense to play also.
So maybe we can play the Automate one.
Okay. We'll go back in about a minute and a half. This is also very cool.
Yeah.
Over the past 2 years, Noble Machines has grown from a small team working in stealth mode to a company set to disrupt how hazardous and physically demanding industrial work gets done. The journey began at NVIDIA GTC, where Moby stepped onto one of the biggest stages in physical AI, surrounded by the next generation of robotics, seen by the people shaping the future of the industry. That moment helped set the stage for what was next. More conferences, more demos, more conversations, more proof. From there, the momentum began to build around the world. In April, Noble Machines was presented in Europe at Hannover Messe with Scheffler. The journey continued across Asia at GTC Taipei Computex, with partner 80Link, where Moby became a standout presence, performing live, drawing attention, and showing what physical AI looks like in motion. From GTC to Computex to NVIDIA GTC Taipei, Moby was no longer just being demonstrated. Moby was being recognized. Now, that momentum comes to North America at Automate 2026 in Chicago, where Noble Machines continues the journey, invited to speak and share how physical AI is moving beyond breakthrough moments and into real industrial value. Robots that do not just demonstrate the future, but prove their value in the real world.
Absolutely amazing. I have to ask you, because I said at the beginning that you guys basically went from founding to shipping in 18 months, which seems pretty phenomenal. Tell me, because I'm sure that a lot of people watch, a lot of developers, a lot of people also on their startups who would love to know, like, what advice or how that happen so quickly?
So I credit mostly to my teammates. So we have 4 founding members, and for example, my two of my co-founders have decade experience in building humanoid robots. One our CTO, he built the first running humanoid at the Caltech, and my co-founder Chris, who was the chief engineer of NASA's humanoid Valkyrie. And for myself, I'm autonomous driving background, so I'm the least relevant to humanoid when we started. But when we come together, we have a lot of experience in making humanoid robots, so we know what to do, what not to do. That's the biggest reason we were able to move fast. The second reason is really we were started in the right time. So we started 2 years ago. So at that time, most of the locomotion and the whole body control has moved from traditional motor predict control into learning based. So we embrace that and be able to train the robot in simulation rather than hand coding each motion of the robot. And also the tools are much more available. For example, NVIDIA already has the Isaac Lab, which really facilitate the development speed. We don't need to rebuild the training environment. And also GPU, right? Like you guys are really good at GPU, and that help us to massively parallelize the training. Hardware cost, hardware is more available and cheaper. Like actuators are commoditized and cheaper, and sensors, because of autonomous driving, is much more available and much cheaper. So when this come together with the right team, that's how we were able to move so fast.
That's amazing. And Johnny and Nasir, don't be shy. If you think of anything you want to ask, feel free to jump in. I did want to ask, because you touched on Isaac Lab, and there are a lot of people watching who are working with both Isaac Sim and Isaac Lab. How did the policies trained there actually hold up when you did transfer to the physical robot? What was the results like?
Yeah, so I think you're talking about the biggest challenge is really the Sim2Real gap. Right, for most of the developers, is actually much more difficult for us because we build the robot for industrial work. That means the robot has to be capable, like handling payload. That means have more powerful actuator, means heavier system weight. So the Sim2Real gap, when there's Sim2Real gap on for example, in the actuator, if in a simulation environment the actuator output a torque that the physical actuator cannot achieve, the system is not going to work. So the Sim2Real gap for us is a pretty uniquely large challenge. So how do we solve this? Is by combining the real hardware data and also the simulation environment. To on one direction, we try to increase the fidelity of simulation by leveraging hardware data we collected from the robot. We are also collaborating with Scheffler, exploring further on that direction. So on the second direction is really how do we bring in our insights in the physics from the classical model predict control? Like how do we what are the common tricks we have in MPC to bring that into the reward shaping in the curriculum design to make sure the model training simulation is much more robust with the residual Sim2Real gap. Like one example is like when we randomize the training parameters, some parameters matters more than others. Like the center of gravity distribution probably matters more than the friction on the joints. So then in that case, we'll randomize the center of gravity distribution wider range. So like combining physics insights into the training also helps a lot.
Very, very cool, and super helpful insights for everybody. So thank you so much for sharing. You talked, so you're working with some great companies, obviously. You just mentioned one of them. You're also working with AdLink, and I'm curious what that relationship is about, what you're building together, what's the plan there?
So we're collaborating on edge computer based on Thor. Thor is the hot new thing in the robotics market. It's very exciting. You can run large scale foundation model on edge. So our collaboration with AdLink is bringing that capability into an industrial grade computer. So we can deploy the robot into more challenging environments. Like for us, because we focus on customers in like construction, in manufacturing, so it's like the reliability requirement for the edge computer is higher than research and consumer grade. Right? For example, we want to reduce the amount of USB. We use GSML for cameras instead of USB, and also more dust and moisture repellent capability than open enclosure. So those are some of the collaboration we are working together. I'm very excited. It's going to be available to the public.
It's very exciting, actually. And I'm sorry I said ad link. It's AD link, right? That's the right way to say it.
Different people say it's tomato.
Okay. All right, cool. I just want to get in trouble. All right, that's awesome. And so you're doing a lot and working with some great companies, like we just mentioned. Where does Moby go from here specifically? What industries or environments? We talked about construction. You showed some great video there. But what are you targeting next? And kind of what's your roadmap like?
Yeah, so like we try to achieve a goal of like be able to deploy a robot as fast as onboarding a person. We're not there yet, but we are trying to achieve that goal. So that requires two things. First is the very reliable and solid foundation that involves the hardware system, the body control. Like make sure the robots, the platform itself can go to different places and do different things. That's the foundation for doing a lot of useful things very fast. Second is really building the AI system that's capable and be able to understand the human intention and workflow. Like one of our customers, they mentioned that what they expect from a general purpose robot is that like the operation wise, they want to be similar to how employees onboarded. Today, in their factory, a supervisor can train an employee can train another employee. So what if we can build a AI system that can help the supervisor to train a robot? So like much faster, much intuitive, rather than coding, rather than like a lot of teleoperation, but more like just talk to the robot, show the robot, and the robot can train another robot. Well, it doesn't need to train, just copy the software. So that requires us to build the infrastructure, the data pipeline, and like the training recipe to enable the onboarding experience.
Absolutely phenomenal, so exciting. Lots of people are watching this. I just got a great question come in from LinkedIn. I'm going to put it on the screen. I know you only have a minute or so. This is coming in from LinkedIn. Like I said, hi Wei, does your computer use NVIDIA GR00T N17 to deploy manipulation policy, or do you guys use your own foundational model?
So we use like GR00T N1.6. We actually went to we have two booths at GTC. If you were at GTC this year, we run two autonomous tasks live. So that was powered by N1.6. So we are also testing 1.7 now, and we are looking forward to 2.0, obviously.
Amazing. Okay, I think everybody is. All right, I think there's another question. How do people get in touch, and if they want to work with you, how does that work?
Go to our website and put your email, and we'll reach out to you.
All right, it's very direct. That's awesome. Wei, I can't thank you enough. This is so fantastic, and thank you so much for preparing the videos. Anytime you want to come back and share new developments, you are absolutely more than welcome to. Lots of great positive comments in the chat coming in. So thank you so much, Wei. It's really, really valuable to have your expertise here and insights.
Thank you very much. Thank you.
Thank you, Wei. That was a treat. What did you think of that, Johnny and Nasir?
Yeah, it's so interesting talk. I was following that company. Recently, they announced the Newton issues that they are working on the new Isaac, etc. So it's amazing. Yeah.
Very cool. Go ahead, Nasir.
Yeah, so it's interesting to see companies bringing real use cases, because that is what the industry usually is struggling when we're in a new area. So it's very interesting to see companies going through all these challenges.
Yeah, I think it's so cool. And what I love is that Wei was very open and transparent to come here and share his story and challenges and successes. I think that's so helpful to the development community. So thank you, Wei. We really appreciate it. And congratulations on what you've accomplished with Moby in such a short time. All right, we're going to shift gears and go to our second segment now. This is also very exciting. Elaine and Yujang from Seed Studio are going to walk us through an end-to-end developer path with the reBot arm. from collecting calibration data all the way through running policies on real hardware with Jetson Thor. And like we mentioned earlier, they're also launching a new physical AI course. We're going to talk to them about that. It's designed to help developers bridge that sim-to-real gap we've been chatting about. Let me bring Elaine up and Yujing. Hey, there you go. Hello.
Hello,
Hi.
everyone. It's great to be here, and thanks to Waze Share. Yeah, we see Isaac Lab and Groot. They're very important and necessary for using for today's industry robots. And once the startups and companies want to bring to their different robots. For Seed, so we work a lot around the developer community. So whether you're a AI engineer or now you're just starting on the journey of the physical AI. So that's why we prepared this course. So basically, this course is we collaborated with NVIDIA. So this is a end-to-end Sim2Real VLA pipeline, and using our reBot that is a open source project of our robot arm, and based on the NVIDIA Isaac. So this course we try to make it as short as in just the 20 plus learning hours, but we want to let everyone can learn the most latest technology for physical AI, and also coming from the NVIDIA. So for this course, we designed this course for two type of the groups. So first is for academic. They want to learn the physical AI, no matter the teleoperation, data collection, or the policy training. And another group is we design for the AI engineers, like they are like other startups. They want to apply the asset, the simulation, Sim2Real, or the Groot policies to their current robot applications. So we want to, they can leverage this course to go through this different pipeline, and then finally they can build up their own application. So in this course, we use our first task is the table cleaning. So we want to use this as an example, and later, after you have learned all the skills in this course, and then you can move this to the other applications. Yes, so our course here. So basically, we separated this course into the four main parts. So first is the teleoperation parts for data collection. Or later, we will also share we'll share the different parts with a lab demo, and so that audience can see that. So first is the data collection, but what is the special for this course is because we use the Groot 1.7. Groot is a foundation model provided by NVIDIA, and the foundation model is support the different types of the data sets. So first is the real robots data sets, and then it's the synthetic data, and then it's the video data sets. So in this case, we combined these different data sets. First is we use our teleoperate. We use our leader arm for the teleoperate, and second, our robot arm is sim ready for the Isaac sim. So we use the Isaac sim for synthetic data. And lastly, we also use the Cosmos video to video to augment to generate the augmented the video, and then we combined these three different types of data sets, and then to train a Groot 1.7, and then finally we deployed to the NVIDIA store. And also you can also choose to deploy this policy to the NVIDIA Jetson All-in Nano. Yes, so I think we can. So Edmark, I think we can bring our robot to the stage, and then yes, we can have a look how we present the different
amazing
part of the pipeline.
And I have to say, right off the bat, I can't believe how you were in this course, the whole walkthrough you just shared, how it's bridging a virtual sim with physical development in such a tidy way. from end to end. Very cool. All right, let me bring your awesome stage up here, and I gave this stage a little name of a robot. There's a QR code on the bottom there, which will bring you to the course, which is great.
Right.
Okay, I think we can see it. And let me see. I'm going to make the screen bigger. Let me see if this works.
Okay.
There we go. So Elaine, you could talk us through what we're looking at here.
Yes. So now you can see we demonstrated this teleoperation. There are the white one is the leader arm. The other one in the light box is our follower arm. That is our reBot. So not only we provided the course content, we also provided the full the light box. All the components, all the hardware components in this course. Yeah, so this is the one the leader moved, and then the follower moved together with the joint movements and the motion trajectories.
So all the hardware you mentioned is included in the course?
Right. So for the course, so the course itself is free, but we also provided also you can the audience can purchase all the hardware components together with a package at seed.
That's amazing. That's so great. And for those, I apologize that our little name icon is blocking the beginning, but of the label at the bottom that says Sim2Real VLA Learning Path, and that QR code will bring you right to the web page. Very cool.
Yes, and so this will be the first step. We collect the real robots data.
And we've got one question.
Yeah, go ahead.
Go ahead. Which is the platform that is running the calibration and the teleoperation?
The platform for the
yes. So are you using reBot from Hugging Face?
We use the reBot. So the for the whole pipeline. So basically, we are based on the reBot training. So all the Hugging Face reBot supported policies we are also supported. So it included the GRUT, but also we have other policies like ACT, imitation learning, and also Pi 0.
Very cool. And I got to put this comment on the screen right away because it's coming in from Omniverse Ambassador Kamadi Richards, one of my good friends. Also, he was just on the live stream last week. Big congratulations to 10 Things. They've actually just started recruiting for their first hire. We put that up on the Discord server, so check it out. But Kamadi is asking, can you do the course completely digitally, so without the physical robot, or do you need to have physical hardware?
So for this course, we need the physical hardware because we combine the different type of the data sets, like the real robots, Isaac, synthetic, and Cosmos. Yeah, but if you want to do so for finish this course under this question, you need the physical hardware. But if you want to just check the simulation, the same assets, you can directly go to Isaac Sim because our assets of the robot is already ready, and also the course scenario, the light box is also ready in the Isaac Sim. You can directly check it out.
Fantastic. That's such a good question. I'm sure other people are wondering the same thing, and great answer. Thank you so much. This is fantastic. All right, and I see, are you sharing another screen here that you want me to show off to everybody?
Yes, we want to share Youjang's screen to check our Isaac Sim.
Okay, so you want me to share the studio screen here? Let me see. I think we can all see it. Let me make it bigger. There we go.
Here. It's not the Seed Studio, is in the Youjang's screen.
Oh, I see it. I'm sorry, this one.
Yeah. Yes, we want to show the Isaacs. Yeah. So this is what I was talking about. So this is the Isaac Sim window, and so you can see the background is our light box, and we put on and we have the assets of the pen, the pencil for cleaning the table, and we also have the reBot arm. Now reBot is moving because because of Youjang is also teleoperate. So that is a real to sim part. It's we teleoperate in the real world, but it's mirrored in the Isaac sim. So Edma, you can also bring our robot to the stage, and then people can see once Youjang is moving and the Isaac sim one is also moving.
All right, let me see if I can. Here it is. All right, okay. See it now. Let me make it big. This one here, right?
Yes. So Youjang now is teleoperated using the leader arm, but inside the Isaac sim, the robot is also moving, following up the right one.
It's so cool. It's so great to see this live. Okay, there I see it. Yep. Very cool. We've got some great questions coming in. Let me see. I saw one that we were chatting about. So one person asked, does a hobbyist need a special license to leverage Groot? Because it is open source. And the answer is definitively no, it is completely open and available to everybody. So no barriers there. I think the goal here is to make this as accessible as possible. That is the best way to grow the robotic ecosystem the fastest and the best. Very cool. Johnny and Asia, you guys are in the same studio right now, right? You guys are there in the room?
Yes.
Yes, we're here.
What do you think? Well, right, so I'm very interested in your observations because you work with developers all over the world. You guys literally, I think you just came back from a big conference across the globe, WRC. And let me ask, so you talk with developers at all different levels. How applicable is this course to what you're hearing from the community? It sounds like this fills a very important gap.
Yes. So I think courses like this are very important because now what we see is that the community is quite fragmented. Like it's a startup, each developer is trying to recreate the same workflows all the time from scratch. So having these courses, I think these are great baselines, so people can have like a ground truth and then start experimenting from the same principle.
It's amazing, and a good question here coming in from LinkedIn. Let me put it on the screen here. Seed, how to partner with you guys? Question from Orca Tech Limited for London, UK. So you work with lots of people, I'm assuming, lots of different companies. How do people get in touch with you?
Yeah, sure. So we have the different partnership program for our reBot project. So first, we are open the global workshop. So if you are a makerspace or if you are an academic organization, if you want to host the workshop or hackathons with us, you can partner with us. The other part is we're also looking for the software companies and especially like model policies and data sets. And then because we focus on this hardware, and then we can work with software partners for the different solutions. And also we are also looking for ambassadors. So the ambassadors, if you are hobbyist for the robots and you are familiar with the robots and Isaac, this different tech stack, we would like to work with you to share about our robot projects all over the world.
Amazing. And if people want to check out your website, it's pretty easy to get to. It's just seedstudio.com. And
Right.
there's 3 E's in that seed. So seedstudio.com. Let me see if we got some other questions here that our producers have been flagging. Let me see. This is coming from Carol on LinkedIn. When a robot moves from a successful prototype to real-world deployment, what failure mode surprises teams most, and what evidence proves it's generally deployment ready? This might be better for Asia and Johnny, but let's see. What do you guys think of this one?
Yeah, so nowadays safety and harnessing is very important in robotics. So train first and trying simulation, reduce this gap, no? And then of course then to deploy, of course, in a safety place. You can test your policy that you trained in before. And also it's important, I think that Elaine mentioned before, data augmentation with Cosmos to generalize more your model with more data, and you can bring these edge cases, not that is very hard to find in real world. So I think that all that tools that they show in the courses in the course, like recollect the data from the real world, also collect the data from simulation and do data augmentation is reduce this gap.
Very cool. I'm putting the website up on the screen. I think we shared it in the chat earlier. We'll also add to the description. But there's a great website showing off the course right here, and these are the aspects that Elaine walked us through. Okay, let's take a look to see how many questions we can take live. Okay, this one's coming in from YouTube. How much time one might need to apply this course with no previous knowledge in robotics? So actually, this is a good question. If you're going in completely cold, is this a good place to start, or should you have some prior experience? And then how long will the course take?
So for this course, we think it will take like 24 hours to 20 to 30 hours.
It's like a hackathon. Okay, so 24, 30 hours, and then how much experience people need to have beforehand?
I think if you don't, because we provided all codes, so it's line by line, so you don't need the we don't hard required you have the experience on the building a robot or the building a robot arm, but it would be better before this course you already learned about the Hugging Face robot project. You already have tried Groot or have at least have an overview of the Isaac Groot project.
Amazing. Okay, cool. I love some of these comments coming in. Look at this. This is really amazing. I think I'm going to use it with my students while I'm teaching robotics at high school. That's great. Coming in from Enos on LinkedIn. Thank you, Enos. Great comment.
Yes.
Do you see a lot of that's a great question. And maybe I'm hoping our marketing team is watching this too, because I'm always trying to see if we can do more to help high school students. A lot of our curriculum and resources are kind of more catered to our higher education. But obviously there's so much interest and excitement from younger developers now. Do you work with younger grades in college?
Right, exactly. So because last year we hosted like 10 different hackathons. So in our the hackathons is around the robot and the SO arm and also NVIDIA Jetson RM. So we do saw the high school student joining us, and I remembered the youngest one was just 11 joining us. Yeah, so at our team, we truly believe now the pipeline learning the physical AI compared to the traditional way you learn the robots now is different. So the barrier is getting lower and lower. So first, now we provided. So for this course, we provide a line-by-line course. But actually, if you use a web coding or using the agents, so actually for some environment configuration, you can directly using the agent to help you. So we trying. So we truly believe now is for high school students they can fully do this.
That's amazing. That is so wild. Very cool.
Yeah,
stuff.
it's crazy the trends. We Asier and me, we went to hackathons, developer events, etc. And also there are kids participating thanks to this kind of courses. So it's like an entry point for any persona, for any developer that they want to move to robotics, to physical AI. So yeah.
Yeah, it makes a lot of sense. Look at this question that came in from LinkedIn. This is highly relevant to Commodity, is watching from 10 Things. How far are we for having domestic nursing help using the robots? I mean, I think if you look at 10 Things or watch the live stream from last week, you will get to see his use case. They're building a robot to help in hospitals right now. So check out 10 Things website. Okay, cool. Let me see. For my producer, Amelia, let me know if there's any specific comments you want us to take before we move into the next section.
Yeah. So,
And then, Ling, go ahead.
Yeah. I want to mention for this course, why we build the use the Isaac Sim. That is because of now this robot and the whole thing that is the sim ready. We already enable the USD file for the Isaac Sim. So this is a collaboration work for between Seed and also NVIDIA team. I think Johnny and there can share more about the features of the new Isaac Sim. Yes, for the robot training.
Yeah, absolutely. So we collaborate together with also SimReady team and NVIDIA to bring this arm for SimReady. That means that it's compatible across different physics engine like physics, Newton. Also, it's compatible with Mujoko, so you can use any physics engine, and it's plug and play. You can import the USD file and use it in simulation.
Very cool. I'm looking at some of the comments here coming in. Let me see. I just saw one coming back. Here, it's coming from LinkedIn. San Francisco is ripe and ready for hackathons beyond your imagination. Let's make connection. There are actually a lot of hackathons happening in San Francisco, right? We've been involved in quite a number of them. And you specifically, Johnny, right?
Yes, and I think that you will see more my face end of the year there. I'm moving to HCFO. So yeah, I participate in some hackathons there that NVIDIA was collaborating, and we are very happy to see developers build their projects, also learn from the failures, etc. And the best thing is to share the knowledge. So I'm very, very happy when I go to that event. So yeah.
I think it's such an amazing community. If anyone's interested in seeing more stories, I do repost a lot of them. Johnny actually also posts a lot of great content on LinkedIn. So I suggest, you check out our LinkedIn accounts, and you'll be amazed at a couple of things. One, how much is happening for robotics across the globe and across many different verticals. But also, I think you'll be surprised at the number of jobs that are being offered. So this training that's offered by Seed, I think is great to prepare people for those types of careers. And like I told the team internally, because I think it's kind of a surprise to us too in a way. It's really, really explosive. I've never seen this type of rate of increase in jobs and hiring and looking for talent. From my eyes, it kind of looks like there's a shortage of talent because there's just a lot of people really looking. So I think it's a great opportunity for developers to leverage courses like this, and get involved in hackathons like Johnny suggested. Share your work on LinkedIn. I think that's so valuable. I think you get a lot of good awareness from that. And if you're a little shy to share on LinkedIn, go to our Discord server. We have a Share Your Project channel just for feedback. You can collaborate with others. We've got a weekly study group that happens every Wednesday on our Discord server. It's specifically focused on Isaac Sim and Isaac Lab. That's also a great place, and no commitment, no pressure. You can just listen if you want. Otherwise, you can jump in and conversation. But I think it's just a great community. Okay, let me see. Elaine, did you guys want to show something else?
Yes, I want to share the real demo later.
The real demo. Okay, this is good. All right, let's go. This is going to be great. All right, so where do you want me to share on your screen, on my screen here?
You can bring our robot to the stage.
Okay, so right here, right? Yep. Good.
Yes. So next to the light box that is running on the store. and you can see it's picking up the pen and then into, oh, it cannot shoot into the cabin. Yeah, but it's cleaning the table now.
Yeah, well done. Give that thing a cookie.
I think that I need it for my desktop. So
So we've seen a lot of these types of demos before, and sometimes the accuracy isn't so high, but this one looks pretty accurate.
Yes, and Edma talking about give it a cookie. Actually, in the WRC, we built another demo is leverage the agentic tools. So we use the Cosmos Edge. So now this demo, what you see is, so that is a fixed, it is a fixed a project. We design picking up the pen, that will be all the time, it will be this project. But in the WRC, leverage the agent tool, so we can do the object agnostic. So give it anything, it can pick it up and then put it into the box. Yeah. So I think we can share this project later.
Very cool.
That is also collaborate with Azir and Johnny.
Amazing. So I love these collaborations. Speaking of collaborations, I'm looking at this. I have to put this on the screen. So we had a question come in from Christian on YouTube that was answered in the chat by our Omniverse ambassador Kamade, who's watching. This is also the power of being part of the community, right? Because you can ask a question, and a developer who's watching, and in this case, a live stream chat can answer you. So Christian was asking, if I have a big factory and I want to start doing robotic simulation in it, what would be the best steps to getting that started, right? That's a pretty big question. And we've definitely covered a lot of this when we covered digital twin work, and obviously BMW has one of the best use cases of Omniverse in the beginning. So anyway, great advice from Kamade just a couple minutes later. Kamade from 10 Things, start small, get some aspects working, and then think about a digital twin or Gaussian splats. Yeah, Gaussian splats are all the rage lately. Michael Rubloff has got to come on the live stream soon because he's been sharing some really great 4D Gaussian splats, 4DGS as it's known, really impactful. He thinks it's going to be everywhere soon, and he's probably right. Okay, great. Let me see if we've got any good comments here. We only have a couple minutes left, so also I want to check in with each of you guys. What do you think is the big takeaway from today? So we got a great show and tell by Noble, doing some fantastic work and great collaboration. And then we have also this great learning course from our great friends at Seed. Johnny, what do you think is a big takeaway? What do you want people to remember from watching this live stream today?
I think that end-to-end workflow, it's very important, so they can learn in every step the different techniques like data augmentation, simulation, train a policy, and also that is very important that sometimes people are missing, that is how to deploy and reduce the latency in the real world, thanks to Jetson Thor libraries with TensorRT that it's appearing on the course. So yeah, I think that we have another demo.
Okay,
maybe
cool.
we can show. Yeah,
I just had to know if my producer Edmar, don't end yet. There's a demo. I didn't know. Okay, awesome. I love surprises. Okay, so am I sharing someone's screen? So let me see. So Johnny, whose screen am I sharing here?
Johnny, are you sharing the screen or something?
no, I think that we upload the video to maybe you can share it, Emma.
Oh, okay. So the video's already been up. Okay, I'm a little out of loop on this. I don't see
because
my tips here. All right, so it's in the. Is it the one called Okay? Hold on. Okay, it is. Okay, I just got confirmation. Okay, sorry, we're chatting. I have multiple screens on in front of me, so I'm trying to look at the right one. All right, this is the video that I was supposed to show. Here we go.
Okay, this one, yes. So yes, I was going to speak about this video. So thank you, Johnny. So in this case, what you are seeing here is Isaac Teleop, but in this case, it's controlled on XR with Oculus Quest 3. So in the DLI, is this part covering XR is not explained, but it's directly compatible. So basically, what you are doing with the leader arm, you can do it also on XR. So here you will see the teleoperated. So this is teleoperated, but now you will see some examples which are not teleoperated, and everything works in simulation, even if you don't have the robotic arm. But of course, if you want the full experience, for the DLI, you will need the robotic arm. But in this case, as you see, Isaac Teleop works perfectly. In fact, we improved this is the old example with the SO101. We improved the workflow, and in this case, with only seven samples, so just you doing seven times in VR, you can have quite high success. I think over like 60 or 70% on success after the robotic arm is doing the same example by itself. So yeah, so basically simulation is getting better. So little by little, each month we are reducing the gap from simulation to real. Yeah, and I think maybe Johnny can also explain a quick fun example. Johnny was preparing a demo to show here at WRC Beijing. He prepared in simulation and he sent the demo to see the studio, and the demo worked directly. So, and Johnny didn't touch the robotic arm.
Yeah, but because I didn't have the setup at home, so we prepared with City Studio the first agentic demo using Cosmos 3H, and it's working in the first shot. So it was working in the wheel. So it was very amazing demo that a lot of people were coming and ask questions. So we can maybe in another live streaming showing it.
What I want to say here is that from the perspective of someone watching this video and this DLI, this can look like very difficult, but in reality it is not. Even us, we were very surprised when this demo that we were building, it worked directly on the robotic arm. We were like, oh my God, it works. So it's easier than it appears. So I encourage everyone to try this, to try to follow this DLI. If you can find a way to get one of these robotic arms, find it, because I think the progress we are seeing in robotics, in open source robotics, is amazing.
Yeah, I have to agree. It's pretty amazing. It's awesome. It's hard to pick the right words because it's just so crazy right now. But Elaine, you also have something you wanted to share.
Yes. But firstly, I want to say the takeaway for this live stream. I think now for different audience, if you don't have a robot yet, you can directly try the Isaac Sim to leverage the inside the Isaac Sim, the different robot, and to build up you can still build up the application to train a policy inside. And if you have the robot arm, or if you already have the SO arm, or you would like to try the reBot, we also have the full stack content for you, including this course, and also for software compatibility, we have Mojuku ROS, and also the other policies. And for industries, I think that is also very important and necessary now. We use the Isaac Sim because we realize there really a data set gap now from the Sim2Real. We cannot accomplish the industry application only use the real world data. It has to be combined at current stage. Yes. I wanna so lastly I wanna share a little bit about this reBot, our open source robot arm that is used in this course, and why we choose this robot arm for the course. Edmar, can you here bring to share screen?
Let me see. I think I got a few screens here. Let me make sure I picked the right one. Is it this one? There you go.
Yes, exactly. Yes. So this is our robot arm. So the reBot arm the B601RS that is based on the rope strider actuators. So this is a 6DOF robot arm. This is more targeting for both academic and also industry use. This is 6DOF with the 750 millimeter reach and with a wider operating temperature compared to the SO arm. So if you use the SO arm before, SO arm is 3D printing, and this one is fully CNC, and also the payload is more than 2.5 kilogram. The maximum is the 5 kilogram. And why we choose this course is fully open source, and we think, and also it has a high performance actuation based on the this mechanical design and also its actuator. And further, we have rich and continuously evolving ecosystem, including the Isaac Sim compatibility, and also we built this as the developer friendly and easy to get started. So we have the assembly guides, but you can also directly buy the assembled version. And for the Isaac Sim now, first is the Sim Ready. We support Cosmos video to video, and also we support the Groot 1.7 for different applications. We already have, so for this course is the table cleaning. We also have the other applications you can find on our website. And also we are continuously working with partners for global hackathon. So this hackathon is in this year, we hosted a 2-day hackathon for cooking. So audience participants, they bring the real the cooking dishes to our company, and then they can make pastas. They can make pasta, fried rice. I mean the different the cooking dishes. So this is a real world exaggeration and the deployment using our reBot arm is pretty fun, and also it's deployed. It deployed policy on the Jetson Orin. And lastly, we're calling for the ecosystem to working with us to host the global workshops and become our ambassadors. If you are interested in our reBot, and also leverage it with the different software framework like Isaac, and then to create different applications.
Very, very cool. Fascinating. All right, let me get the screen off. Wow, this is awesome. I also even have some other slides here. Let me quickly, so many things being shared today, so much great news. Okay, so we got a couple of quick news things to share. Let me remove some of the cameras. But Elaine, I'll go through some of the news slides. I'm going to bring you guys down below because I know we're a little bit over. But thank you so much. This is a fantastic presentation.
Thank you.
Really, really honored that you were able to share everything with us today, and I can't wait to see the kind of results you get from your first student. Look at Asir, Johnny, what are you guys doing? Man, I wish I was over there. Right
AI.
now.
This is AI. Now we have better light here, better light, studio light.
Amazing. Well, so glad for each of you joining us today. It's been really, really fantastic. Good, best of luck and congratulations with the course. We'll be sending a lot of people your way. Let us know. Let us know when you want to come back and share any updates.
Yes. Thanks for having us again.
Thank you. Okay, and I think right now we've got some news slides to share. Let me put these up on the screen. Okay, so we just kind of had a great about an hour or so. Went a little over because there's a lot of stuff to go over. But here's a QR code if you want to find more about how Noble Machines is accelerating general purpose industrial robots with Isaac Groot. We were very honored to have the CEO here, Wei, who went through everything and shared some fantastic videos, very compelling, showing their especially construction use case and a nice walkthrough. So if you want to read out more about it, go to that QR code for a nice blog. And obviously, we just had the wonderful folks from Seed on. So you can follow this link to find out more about the Sim2Real VLA pipeline with this reBot arm. I don't think it's reRot. Whoever did this slide, I think it's Mara. Mara, it's not reRot, it's reBot. NVIDIA Isaac. That would be a funny name though. So check out that QR code. These slides came in very hot, so I'm making fun of Mara, but yeah, she just did this a few minutes ago for us. So thank you, Mara. That QR code will bring you more information about the reBot arm that she just introduced a minute ago. Elaine just introduced. And then, oh my God, speaking of introductions, this is amazing. We just announced this, I think it was yesterday, introducing NVIDIA Jetson Orin Nano 2. This is amazingly impactful. I'm seeing excitement, lots of reshares on this news across the internet. This is going to be available very shortly. That QR code will share all the details about the Nano 2 brings to the table in terms of increased efficiency and power in the same footprint, which is awesome. I cannot wait to see what developers are going to do with these extra resources and performance that's going to be available in the Nano 2. So if you are really excited about this, absolutely, please post and share this. We would love that. Feel free to tag me. I'll amplify it. Let us know what you're planning to do and what this will help you achieve. And of course, when you have it in your hands, those of you who get it, absolutely share your projects. I think that's one of the most interesting things for us to see every day. So thank you for sharing your project with us. Speaking of sharing, the golden ticket is upon us. They're doing this now for GTC Berlin coming up October 20th to 22nd. I'll be there. Amelia will be there, our producer who's helping in the background. Really exciting stuff. We will, so basically how it works is, let me actually share my other screen here. Let me see if I can do this. Because I have the web page open. So basically how the golden ticket works, you, does this end pretty soon? What's the expiration date here? You have till September 14th. Okay, so you've got some time. But what you want to do, you want to follow the team members listed below, and each will help award tickets based on the entries, sharing on what you're building with open models. So to enter, you post a short video, drop a link to your open model project on social media, tag the judge you heard about the challenge from, and include the hashtag NVIDIA GTC. Do not get this hashtag wrong, or else you're going to have Greer come knocking at your door, and you do not want that. So NVIDIA GTC hashtag to use. I'm talking backwards, but you get the point. And here are some. And here, Asir was just on the live stream a few minutes ago. So you can follow Asir, Jen, Ray, Sharuk, George, Johnny. Oh, Johnny also. Awesome. Merv and Steve. So feel free to follow those folks on LinkedIn. The webpage is in that QR code. Maybe we can put this also in the chat so that you guys can go directly there. But I encourage everybody who wants to try to attend GTC Berlin and you want to try to get a free ticket out of it to go ahead and do that. And why can't my mouse? Okay, here we go. Let me switch screens here. Okay, there's a golden ticket. Hope to see you there, whether you get the golden ticket or not. Let us know. We've already set up a WhatsApp group. Hey, look at this. Nicholas is gonna come. That's amazing. And he's going to. Oh, he's planning to win the golden ticket. All right, Nicholas. Good luck to you. I like your confidence. So NVIDIA is coming to Berlin. That QR code will give you all the details. Like I said, we've already set up the WhatsApp group for community members who are attending. So if you're going, let me know so I can add you to that very private, exclusive group with other community members. Some really great, amazing developers in there, I got to say. And they're already chatting about GTC Berlin and getting plans together and talking about how to strategize, make the most out of your time there at the show and with each other. We're going to have coffee meetups, of course. So we have a dedicated Discord server channel. And Asir and Johnny will, I'm just getting this word in our chat. Asir and Johnny will also be at GTC Berlin. It's going to be amazing. So this is coming up in October 21st, 22nd. Learn all about it with that QR code. The keynote is on the 21st. So I hope to see all of you there. You know, you can chat with the community during and after the stream, even when the stream is over and it's a distant memory next week or something. You can still chat about the specific stream. We've set up a live stream channel on our Discord server. In that channel is a thread for each live stream. So that QR code will bring you right to the live stream channel. So this QR code will always work. It's a permanent link to the live stream channel. And then just you could scroll through the different live streams. If there's a live stream there that you missed or that you were part of and you want to ask a follow-up question, other viewers might answer, or maybe one of the panelists will stop by in the thread and check in once in a while. But use that QR code to chat after stream. So whether you're watching us live or watching the replay, that QR code will bring you right to our Discord server to chat about it. Here are some other resources that are always helpful. Our Ed event calendar, which will show you our live streams, our office hours, our study groups, of which we have 3 right now. We have 2 OpenUSD study groups that take place every Friday, and we have an Isaac Live study group that takes place every Wednesday on our Discord server. So find out about all that stuff and the events QR code there, which is our Ed event calendar. And then for support, I would actually encourage, we have to update this slide because I think we want to encourage people to leverage GitHub issues. Most of our stack is now firmly planted on GitHub. So our engineers are hanging out in the issues area, helping people. The response time there is fast. So go there. You can also use the forums. It's a great place to come hang out with other people as well. And we do have our engineers there too. But I would say GitHub issues is a top place to go for support. And we always talk about the Discord server. There's a QR code for the NVIDIA Omniverse Discord server. I hope you join. Lots of great channels there. I got to say, a couple of channels which I love. Share your project. We're seeing some great work shared regularly by developers, giving really peeks into their workflow and pipeline, what they're doing, and you can give feedback. And then we have a nice job board actually, which yours truly has been populating every day. So all those jobs are basically posted in nearly real time. As soon as I see them in my feed, I try to pop them in there. So there's multiple jobs posted every day, varying experience levels. So that's another reason to stop by the Discord server. If you or you're helping your friend land a nice job, check out that job board channel. And then our community page, the last one, is where you can find out about all our ambassadors, including Commodity Richards, who's watching today, engaging with viewers in the chat. I hope to see everybody at an upcoming event like GTC Berlin, or perhaps maybe GTC